Thank you for the opportunity to present to the Australasian community. So good morning from Spain. I'm connecting from Spain at the moment. So sorry if it's a bit, the internet is not very good. Try to get the best connection. I'm Sofia Samper Carro. I'm one of the, I'm a lecturer at the Australian National University. And as Emily was mentioning, I'm presenting this talk on behalf of a lot of my colleagues from the Universitat Autònoma of Barcelona in Spain. And today what I wanted to share is our progress and our plans for Sugar. That is our self-developed software for the management of archaeological data. So in this talk, I have divided it into two parts. So the first one, I will explain kind of the workflow and the work philosophy behind the project that we are proposing. And then I will introduce the software with a very short video where I'm showing the interface and some of the options we provide to enter data. So as archaeologists, the way we approach archaeology is we specialize in excavating multi-layer Pleistocene and Holocene sites, mostly in Europe, but as I said before, I also work in Ireland, Southeast Asia. So one of the strengths of our software is its ability to handle complex archaeological sites. So here in Spain, we usually deal with overlapping occupations in large excavation areas. So we just finished excavating a site that is like 40 square meters. So very large excavation areas. The platform, Sugar, what it ensures is all the artifacts and the features that we find during our excavations, they can be contextualized with precise 3D coordinates. And for that, we use different tools in the excavation process and then in the lab management of this data. So as I was mentioning, our methodology integrates field tools such as laser theodolites, such as total station, and tablets to register the data we find on the site with then tagging or labeling the artifacts with pre-printed codes, with what we call data matrix codes or QR codes. What these methods allows is to have a continuous workflow from the field to the laboratory. All this data go into a relational database that is created. It's built from the creation of the field nodes and expanded with the artifact analysis and with the daily reports to ensure that we have a correct correlation between these fieldwork artifacts and the lab. So the process that I will describe in the next slides is detailing a publication. Unfortunately, it's only in Spanish at the moment, but I'll show you another reference of another publication where we explain the whole process. That one is in English. So one of the good things we have with the field, the type of recording we do on the field is we can adapt it to any kind of grid method. So it can be used in the case that you are excavating using a floor grid or an aerial grid. What we use usually is a virtual grid. So here on the bottom of the slide, you have some examples of Roca dels Bous, one of the sites we excavate this summer. So to do that, or to integrate the database with what we do on the field, we have like a light version of the database that it's uploaded to these kind of tablets. The ones we have now are a bit more updated than the one in the photo. But then that help us to record all the data during the excavation. We have Wi-Fi connection with like a portable Wi-Fi router that enables this simultaneous work on multiple devices and streamlines field data management. So at the end of each of the working days, the software automatically merges the spatial data that we recorded from the excavation and the information collected in the tablets, where we record what have we found in this specific 3D coordinates, and then it has full connectivity with the PC or with the cloud. We then use QR codes or data matrix to label the pieces. So these are high durable labels, and we've been using them now for 17 years. Trust me, I try to destroy them with all the methods I could think of. It's impossible to destroy. Even this year, somebody forgot some labels on their pants, on their pockets. They went through the washing machine and they are still applicable. So they are very small labels. They are just stickers that you can attach to the piece or to the bone, to whatever artifact with some paraloids, with some glue. And the smaller size we have is 2 by 2 millimeters. So they really fit in very small artifacts. Even though they are very small, they provide enough space to replace traditional labeling, but also to have or to cover all the data we record on the field. Once we label the pieces, these codes are read with laser readers, which automatically open the registers in the database because we have already entered it on the PDAs, on the tablets. And as I said, this will substitute all the conventional codes. It also eliminates mostly or almost 100% human error in cataloging. So all the problems with writing numbers or numbers you cannot read in 20 years time. So it's a really good alternative to traditional labeling. As I was mentioning, for this system, we have a publication that you have, it's probably very small, but here on the top of the screen, that is called Data Matrix Codes, and we published in the Journal of Cultural Heritage in 2011. If you are interested in learning more about that workflow. So this methodology we are presenting, it produces a complex relational database that organizes all data into basic folders that contain spatial information on the geology, the topography, the archaeological units, so like the occupation floors, and the features we found on the site. So from this data on the field, then to the laboratory, the QR codes facilitate the search for any of these artifacts and also the entry of new data on the database. All of this is tied to our software. It used to be called Archaeology, now it's called Sugar. And where all these relational databases and tables are hidden and everything is displayed on a screen via a user-friendly interface that I will show you in a second. The software can be used to track all kinds of data related to the research, including spatial data and object attributes, but it can also produce graphic outputs that provide visual representation of the floor plans and the 3D surfaces we are excavating. In this way, we hope this enhances both interpretation and hypothesis testing. The next slide, there we go. So in terms of the system of representation, these are just some examples of the kind of maps we produce with the software. So we introduce several graphical representation tools. So we can automatically generate files that contain the floor plans like you have here on the left of the screen. And this is again an example from Rocadel's bows. We can create vertical sections and we can draw different features within the archaeological unit. So for example, here on where it says floor plan, we have with the dots, we have all the artifacts that were found on that archaeological unit. Here on the right, where it says structures, on the center, all these circles or elliptical shapes you have here, these are the hearths we found during the excavation, so we can integrate those on the representation. And then you have in yellowy, the rocks that were found. So we can integrate all this information to understand how, in this case, Neanderthal communities were occupying the space and how they were using this space. Then we can create these sections that I will show you in a second, a bit more information about that. And we can also create these 3D features of seeing the topography of the site. So as I was saying, another of the options that I have to say I'm one of the most fans of is the creation of automated sections. And this is a very useful tool in the field and in the laboratory because it allows us to virtually navigate to different parts of the site. So the theory behind it is we get all the representation of the points. If you imagine this is an archaeological site, this is a lot of artifacts, and it's very difficult to understand what's happening. So what we are doing is kind of a cake. So we are slicing the site into vertical sections, as you can see here on the bottom, and we can see small chunks of that site to understand how the archaeological units behave, the geometry of these archaeological units. The software can generate these sections in different thicknesses. And that offers a very high resolution for interpreting large excavation areas with inter-stratification of several occupations. And it also avoids what we call the stacking effect. So here I just added some examples. For example, if we take a section that is 2 meters thick, what you see is a lot of points because there is a lot of material. But when you start decreasing the size of your sections, it also increases the resolution. So when we get to this 0.125 meters, we can really see a clearly defined unit that we can interpret. And this is what we were talking about, the stacking effect. So if you are adding a thick section of the site and you put all together in the Y plane, then you are going to get a large quantity of points. That is different if we are cutting, let's say, through here, where you just get a few of them. Sorry, that one skip. Okay, so now I'm going to show you a short video of what is the interface from Sugar. So this is the main interface. So far is it is in English, but we have to use the Spanish version for this demonstration. So here you have all the administration tools, so you can export or import data. You can even integrate Excel files and integrate it in that. We have all these dictionaries or thesaurus where we can add any data we are interested to have on the database, so we can then use lookup tables to enter any type of information. Then we'll go into the analysis of the pieces. So there where it says projections, those are the sections. We can also create inventories for the sites, for any site, and we can also do some statistical analysis in terms of density, counting, refitting, all those kind of things. So this is the screen that you will see when you enter data on the software. You can either select a archaeological unit and enter the number manually. And there you have a kind of the record of all the artifacts that were coordinated on that archaeological unit. And this is how we will enter the codes. So they just got scan, it appears a number there, and this will open the interface where you can enter all data of the artifact. So we have different options. We have typology, we can enter measurements. These are some specific details for lithics. I have to say my colleagues are specialized on lithics, so most of the database have a lot of utilities for lithic analysis or stone artifact analysis. As I was saying, you have then the lookup tables that you can use to enter your data. Again, all this is being translated to English at the moment. All the different tools. Here on the top, you have kind of more specialized analysis. So the first interface is more for students or people coming to the site. They enter the first kind of record, and then we can go into these screens, those tabs on the top to, for example, I analyze bones. I can go and analyze bones in my case, or lithics or pottery, whatever you want to analyze. Let me see if I can pass to the next slide. It doesn't like it. Now it does. All right. Sorry about that. There we go. So our current goals are to expand our user base and enhance ease of use and virtual interfaces based on the feedback we get from users. So Sugar enables the social sciences and humanities to embrace this digital transformation. And we hope that this software will enhance data management within the sector of archaeology, in our case, and set the stage for future collaborations that will transform the global handling of data. So just as a summary, what Sugar is proposing is an innovative and open source data management software that allows merging all data that are recovered from the field in an intuitive and user-friendly environment. At the moment, what we are doing is exploring how it works when we use it outside the Universitat Autònoma of Barcelona environment. We have some stakeholders in different institutions in Spain. At the ANU, we are also testing it with some material. And we anticipate that a multi-language release of the software for stakeholders, it's all going to be free of charge, as it was mentioned on the previous talks, it's open source. We are following FAIR principles. So we anticipate all this release by early 2026. So thank you very much to the organizers of the conference. And this is a contribution to the research group led by my colleagues at the Autonomous University. And if you are interested in testing sugar, see how it works, please send me an email and I'm more than happy to share a copy of the software with you. So thank you.